Alright, this is Mr. Gillum, and today we're going to learn some more about the distributive property and combining like terms. And we're going to add one more step of difficulty to the mix today. We're going to throw in some subtraction signs, otherwise known as negative signs. So let's take a look here, and these should look a little familiar because they're very similar to the notes that we've done before on the distributive property and combining like terms, but they're good to review as well. Remember that like terms have to have the exact same variable parts, so x's cannot get squished together or combined with y's. Constants have to stay only with constants. If there's any exponents on the variables, those need to stay separately, because a 3x squared and a 2x, the variable part is the part in the box, and that variable part does not match exactly, so those terms have to stay separate as well. The number of terms is easy to forget. There are two terms here. They're separated by an addition or subtraction sign. So the number of terms is dictated by how many addition or subtraction signs that you see. The distributive property, again, here's your quick review. If I had 3 times x plus 2, I would multiply in 3x plus 6, or if I had 4x plus 8, and I know their greatest common factor between 4 and 8 is 4, then the 4 could go on the outside. And 4 times x would be 4x, and 4 times 2 would be 8. All right. So that's the distributive property, forwards and backwards, and we've been talking about that as well. But today, like I said, we're going to add that one more step of difficulty, okay? We're going to add that one more step of difficulty. Now, as you can see, things have changed a little bit. Instead of just all addition signs, we now are throwing in the mix some subtraction signs. And so, I need to be careful I say this because things change a little bit as you get into more advanced algebra. But for now, what I want you to keep in mind is that the signs of a term, the sign in front of the term stays with the term. Let's say it that way. So I'm going to do another little quick example here. If I had 3x plus 4y minus 2z plus 4, okay? I know that none of these are like terms, but I see that there are 4 terms there. 3x, 4y, negative 2z, and 4. And so when we talked about like identifying coefficients and constants, when we talked about the coefficient in front of z, we didn't just say it was 2, we called it negative 2. Okay, it would be the coefficient. And the reason being is because that subtraction sign is taking away, and so we call it a negative 2, getting smaller. So I guess the point I'm trying to make is whatever sign is in front of the number stays with the number. And whatever sign is in front of the term stays with the term. So this is a positive 4y. This is a positive 4. This is a negative 2z. This is a positive 3x. Now keep in mind, if there is no sign in front of the coefficient, then we know it to be positive. All right. So I guess here we go. Let's just see what happens. I'm going to take 3 times 2x. And because these are both positive numbers, I can say that that would be a result of 6x. In the future, you will learn that any positive number multiplied by a negative number is a negative value. But for now, what I want you to do is this. I want you to just think of this as a subtracting 3. And now I'm subtracting 3 times as much. So I'm not just subtracting 3, I'm subtracting 9. All right, so I had a positive 2x, now I'm subtracting 6x. Or I have 6x, and I was subtracting 3, but now I am subtracting 3 times that. I'm subtracting 9. All right, so we're just throwing that minus sign in there. I had 3 before, and now I'm going to multiply it by 4. That makes 12. I was subtracting 5x, but now I'm subtracting 4 times as much, so I'm subtracting 20x. All right, and again, I'm going to stop right there because I have no like terms. I have a constant, negative 9, and a variable term of 6x. So 6x minus 9 would be the correct answer. Correct simplification, I should say. However, we talked about this a little bit yesterday. What we would like for us to happen is to have our variables come before our constants. And so this is what I was talking about up here. All right. Because this 20x has a minus sign in front of it, And because this 12 doesn't have a sign, I know that it is a positive 12. And so if I'm going to write this problem in order, I would like for the negative 20x to come first because it has a variable part. So the best answer would be minus 20x, or negative 20x, and then because this 12 did not have a sign, we know that it is positive, plus 12. Okay, and so that might be confusing because that's just when we're starting out. We're not real familiar with negatives yet, but I just want you to keep in mind that the subtraction sign, or the sign in front of each term, stays with that term. So the best answer would be negative 20x and then positive 12, or plus 12. Negative signs and subtraction signs in the end all mean the same thing. All right, so let's see if that becomes a little more clear here in a second. We're going to start using the commutative property to help us combine our like terms. So let's take a look at this next problem. And again, it's really similar to the one we did before, except for something has changed, and it's that minus sign there. Okay, and so what I'm going to do is I'm going to distribute like I had in the past. I'm going to take 2 times 3x, which is 6x. And I was adding 2y, but now I want to add twice that, so I'm going to add 4y, 2 times as much. Okay, so I've distributed the first term. Now the second term, again, if there is no coefficient in front of the parentheses, we can pretend that there is a 1 there, because the identity property says anything times 1 stays the same. And if we don't want those parentheses, but we still have operations, we need to distribute. So I'm going to distribute. 1 times 2y is still 2y. And I'm subtracting 5x one time, so I'm still subtracting 5x. All right? But now we have a dilemma here, because subtraction is not commutative. It doesn't flip-flop. It can't be 6 minus 5 is not the same as 5 minus 6. And so this is also very, very important that we keep in mind that the sign in front of the term stays with the term. Okay, so we have a negative 5x and a positive 6x. Now I know there wasn't a plus sign in front of the 6x, but we know it's positive. Now the commutative property is okay to use with subtraction as long as the subtraction sign stays with the term that it's next to. All right, and so what I'm going to do is I'm going to rearrange the order. Okay, I'm going to rearrange the order of this problem. I'm going to put all the x's right next to each other and all the y's next to each other, and then I'm going to do the problem. So just to make sure we're clear, that plus sign goes to that 4y and that plus sign goes to that 2y. So what I'm going to do is this. I'm going to rewrite the 6x, and instead of writing the plus 4y plus 2y next, I'm going to rewrite the next part that is a like term, the minus 5x. Okay? And then I'm going to write the last two terms that are also like terms, plus 4y plus 2y. And so now, although it's in a different order and subtraction doesn't follow the commutative property, because I kept the subtraction with the term it was referring to, I can just do 6x minus 5x. So if I had 6x's and I subtract 5x's, I just have 1x left. But I don't need to really put the 1 in front of the x. It's understood that there's a 1 in front of the x, so I just have 1x. And sometimes students like to just drop off the variable in this part because they say subtraction and oh, x minus x is nothing. But we're talking about 6 of something. 6x's minus 5x's would leave 1x left. So 4y plus 2y wouldn't be 6y squared, it would just be 6y. 6 y's. So 4 y's there and 2 y's there makes 6 y's total. Okay? And now this looks like a good answer because I have an alphabetical order. There's no constants to worry about. So let's go to the next problem here. And again, this one's just a little different as far as what the numbers are, but we have a subtraction sign. And so that's the difference. So we're going to just distribute the same way. 6 times 3x is 18x. And the way I would like you to think of it today is I was subtracting 1, but I want to subtract 1 6 times. So instead of subtracting 1, I'm going to subtract 6. And then again, I don't have any operations inside these parentheses that I can simplify. So to get rid of those parentheses, or to remove them, I need to distribute. So in this case, I'm going to distribute the 4. Plus 8y and plus 12. Now again, I have different parts of my like terms in different places. I see that 18x is a positive 18x. Okay. I see an 8y that is a positive 8y. But I also see a negative 6 or a minus 6, and that minus has to stay with the 6, and a plus 12. So my next strategy is going to be to write it in an order where I can combine the like terms. So the constants is what I want. I want both constants to be right next to each other so I can simplify. So what I'm going to do is I'm going to write down the 18x because it's in alphabetical order first. And because it's in front, I don't need the plus sign. Okay, I know it's positive. I don't need to write the positive sign. The next thing, if I'm writing it down in the correct order, would be the y terms. So I'm going to go with the 8y second. And I know it's a plus 8y because the plus sign is in front of the 8y in this step. Then it needs to stay in front of the 8y in the next step. Now here's your choice. You can either write the minus 6 next or the plus 12x, or plus 12 next. But if we write the minus 6 plus 12, it would be like saying negative 6 plus 12, which would be kind of confusing because we haven't really talked about how to add integers yet. So I want you to use strategy here. I'm going to say, let's do the positive 12 first and the minus 6 next. All right, and because both of these terms are constants, if I'm starting at positive 12 and I'm subtracting 6, I am then at 6, positive 6. 12 minus 6 is 6, positive 6, so we're going to put plus 6. All right, so these are going to be a little more challenging because we're throwing in the subtraction signs, but just remember we're going to use the commutative property to change the order and get the like terms next to each other so we can combine them. All right? I think the last example has some fractions in it, and I'm going to exclude some fractions. We will come back to some fractions notes here in the next few days. But for now, I just want you to keep in mind that whatever, this is the big important part, whatever sign is in front of the term stays with the term. When I rewrote the 6 down on the next line, I kept the minus with the 6. Okay, so you're going to use strategy to put the numbers in order where you can combine them together easily. All right, that's it for today. Combining like terms in the distributive property, and that's it.